My dear friends, my dear students, uh, today we'll discuss few more concepts related to data structure. It is data structure using C++. In the previous class, we discussed about the fourth module and the concepts related to the queues which are queues related. It is also data structure, and we have discussed about the queues in the previous videos, previous classes. We discussed about the queues which is there in the fourth module, and few more concepts which are there in the fourth module are one of that is hashing means what? Hashing is a effective way to reduce the number of comparisons. Actually, hashing deals with the idea of proving the direct address of the record where the record is likely to store. Suppose there are so many thousand of data is there, so many data is there, then how we can store the data into the memory location, in which location we have to store the data, how we can access the data. For that, using the hashing concepts, we can store the data, and we can retrieve the data using the concept of hashing easily. Suppose, for example, here for example here you see here, for example, this is the key means this is the data. We want to store this data into the memory location. In which location we can store this data? uh, uh, Here you see here, last three digits are 00. Therefore we'll store this data, that is 496700 in the zeroth location, so that we can store the data easily, and suppose we want this data, we can retrieve this data easily. Therefore, this is nothing but using the three digits will come to know, we can easily store this data. Suppose we want to access this data, by knowing the data, we will go to that location, and we can retrieve the data. That is nothing but, this is nothing but concept of hashing. Here, for example, this is the data 495737. In which location we have to store this data? Into the memory. That is, you see here last three digits are 397. Therefore, we'll store this data in the location 397 will store the data 4957397. Like this, using the concept of hashing, we can store the data in a particular memory location, and also it is easy to retrieve the data from the memory locations. Therefore, this is known as hashing. Here in hashing, we'll come across so many concepts. That is hash table. Hash table is a data structure used for storing, retrieving the data quickly. For this is nothing but, here using the hash table. Hash table contains this, the whatever this, all this, it contains these addresses of the memory location, so that we can access this data, store the data quickly. Therefore, this is the table which contains the it is data structure used for storing and retrieving data quickly. Every entry in the hash table is made using hash function. Using hash function, will store the data into the memory location, or we can retrieve the data from the memory location. For example, hash function. Hash function is the function used to place data in hash table using hash function. Similarly, hash function is used to retrieve data from the hash table. A table is there which is having the addresses of these memory locations. Using these addresses, we can store the data in a particular memory location, or we can access the data. We can access the data from the location. That is using, this is the table is the table means a table which contains all these addresses of these memory locations. Then using these addresses, we can store the data in a particular memory location, or we can access this data using these addresses of the memory location. Therefore, using this is called as hash table, and using the hash function, we can store the data in hash table, or we can retrieve the data from the hash table. For example, consider a hash function, a key mod 5, the hash table of size 5. Suppose this is the hash table which is of 5. Then suppose we want to store data 33, we want to insert the 33. In which location we have to insert? For example, 33 mod 5 means 33 divided by 5. At that time, when we divide 33 by 5, we will get the remainder as 3. It means that we have to store this data 33 in the third location. Like here, for example, suppose data is here. You see here, step 2. Suppose we want to insert 54. Where we have to insert 54 mod 4 means 54 divided by 4 will get this 54 divided by 4, then we'll get the remainder as 4. 4 4 4 ones here is a mistake. Here it should be 54 mod it should be 5. Why? Because everywhere this is mod 5. Therefore 54 mod 5, at that time remainder will be 4. Therefore we'll place in the fourth location. Like here also, 25 mod 5, at that time the remainder will be 0. Therefore the 25 data will place in the location 0. That is, a remainder is 0. Therefore we'll place this 25 data in 0th location. The remainder is 3. Therefore we'll store this 33 in third location. Here remainder is 4. Therefore we'll store 54 in the fourth location. This is nothing but hash table. This is how we can store the data into the hash table. So many concepts are there. Like here we'll discuss about collision. Suppose collision is a situation in which hash function returns the same address for more than one record. Collision is what? For example, data is there, 25 is there, 50. For example, if we want to insert 55, then 55 mod 5 is equal to remainder is 0. When we will divide 55 by 5, remainder will be 0. But in the 0th location, 25 is already placed, and because 25 mod 5 is nothing but 0, therefore already 25 is placed in that location, in the 0th location. Therefore we can't place 55 where we have to store the 55. We have to, using 55 mod 5 means we have to store this 55 in the location 0, but already 25 is placed. Therefore this situation is called as collision. Therefore there are so many ways are there, using that we can avoid collision. Therefore here we come across so many concepts, that is probe, synonym, overflow. So many concepts will come across this. You read the book, one will come to know all the concepts. Here I will give the brief idea about all the some concepts. You have to read the remaining concepts, you have to read yourself. What next? Hash table representation. How we can represent the hash table? There is a different key address transformation techniques. For example, hash function is there. There are various types of hash functions or hash methods which are used to place the elements in the hash table. Suppose there are different techniques are there. Using these techniques, we can place the data in the hash table. What are the different hash techniques, hash functions used to place the data into the hash table? That is, different various hash functions are division method, multiplication method, extraction method, mid square method, folding and inversal method. Like different methods are there. Now first we'll discuss about division method. Using this concept, how we can store the data into the into the hash table. In the hash table, suppose seven these are data. What are the data? 54, 72, 89, 37 is to place in the hash table. And if the table size is 10, if the hash table size is 10, then how we can store this data into this table? Therefore the hash function is called to record a modulus of table size. Here table size is how much? 10. Modulus means from record is what? This 54, this whatever the elements, whatever the data, those are nothing but the those are called as records. For example, we want to store the 54. Where we have to store? Because table size is 10. Therefore 54 modulus of 10 means what actually what we are doing, that is we are dividing this 54 by 10. When we divide 54 by 10, what will be the remainder? That is remainder is 4. Therefore this is the 4, means we have to place this 54 in the fourth location. See here, we will store in the fourth location. So 72 data 72 element 72 is there. In which location we have to store? 72 modulus 10. Then when we divide 72 by 10, the remainder will be 2, means we have to place this 72 in the second location. Like using suppose some data is there, if you know the size, if you know the function, hash function, then we'll come to know the addresses in which location we have to place these data. This is nothing but the hash this hash table. This is the hash function. Now then using this concept we can store the data in the respective memory location. Suppose it is why we go for hashing, because using this concept we can easily retrieve the data, or we can easily store the data. Here you see, here 72 is there, therefore we will store in the location 2, second location. Data 54 is there, therefore we will store in the location 4th location. 37 is there, it is the data is 37, therefore we will store in the 7th location. Data 89 is there, therefore the last term is 9, therefore we will store in the 9th location. Some technique you use so that we can easily store the data or access the data from the memory location. This concept is known as hashing. There are different types techniques are there. This is the one division method. In multiplication, where suppose extraction. In extraction, what we'll do? Suppose, for example, here the data is there, 6-digit data is there. That is 4, 9, 7, 8, 2, 4. At that time, what suppose in this what we'll do? In this method, some digits are extracted from the key to form the address of the location in which in the hash table. For example, suppose first, third, and fourth digit from the left is selected for hash key. Suppose this is the data 4, 9, 7, 8, 2, 4. Therefore, from left side, we'll take the first digit, third digit, and fourth digit. Then these 3 digits, that is 4, 7, 8. This is the address of the memory location in the hash table. This is the address of the placed in the hash table to store the data, this data in the memory location. In which memory location we have to store? The location 478. Here you see, at 478 location in the hash table of size 1000, the key can be stored. We store 478, means when we store the 478, means this data will be stored in the location 478. Like different techniques are there. Using this technique we can store the data in the respective memory locations. For example, here mid square means suppose some data is there, let key be 311. This is there. Mid square means here you see, here you will square this one, 311 will square this one. When we square this one, we will get this data 9678321. At that time we'll take only the middle 3 numbers, 7 here, 2 left, leave this 2, will 783. This 783 is nothing but the address of the memory location. That is for the hash table of size 1000, this 783 is the address of the memory location where we store the data 311. Like so many techniques are there. That is mid what is that, mid square and folding. Here folding means folding. Here suppose 9 digit data is there, what we'll do, we'll make group of 3. This is 3 here. In the concept of folding I'm talking about folding. Here first we'll take this 3 4 5 6 7 8 1 2 3 1 2 3, add all this and we will get this number. Discard this one, discard 140, will get 146. 146 is nothing but the address. 146 the address where we can store this data. What is the data? This is the data 3 4 5 6 7 8 1 2 3. That is 3 4 5 6 7 8 1 2 3. This is the data in which location we have to store, in the location 146. Like so many techniques are there. So many, using these techniques we can store the data in various memory locations. Next, one more concept is that there is something but collision. I already told that what collision. What is collision? Collision means suppose two elements, two elements pointing to same memory location. For example, already told that what is collision. Suppose here data is there, 25 is there, 55 is there. Both will point to this location. Why? Because 55 mod 5 is nothing but 0. When we divide 55 by 5, remainder will be 0. When we but here 25 is already placed in the location 0th location. Means 55 mod 5 means 5 means we will get 0, means in the 0th location we have to place 55, but in the 0th location already 25 is placed. Therefore two data, what are the two data? 25 and 55 pointing to same location. This situation is known as collision. Same two or more datas want to place in the same location. This situation is called as collision. Then how we can overcome or use the collision? There are so many techniques are there. So many methods are there. Using those we can avoid collision, or we can resolve we can resolve the collision. We can resolve the collision. The different techniques are open addressing, chaining. Then in open addressing, collision is handled using linear probing, quadratic probing, rehashing. Like so many techniques are there. In chaining, we'll have the separate chain table is maintained for colliding data, and in that we are having the chain. In chaining we are having with replacement, without replacement. So many concepts are there in the collision resolution techniques. Collision resolution techniques means, suppose data 25 is there, 55 is there, 75 is there, both all are pointing to the same location, 0th location. Then how we can resolve this? That is how we can store the data in the hash table, so that because if you divide 25 by 5, the remainder will be 0. Suppose you divide 55 by 5, the remainder will be 0. Suppose you divide 75 by 5, the remainder will be 0. It means that all should point to the same location. All will point to the same location, 0th location. But using the chaining, how we can concept of chaining or linear probing, quadratic probing will overcome the collision. We can resolve the collision. That is about, so many concepts are there here. They have given in the book, they have given how in linear probing how we can overcome the collision using the chain concept. Suppose here these are the data are there: 0 1 2 4 72 65 85 87 90 55, sorry, 58 52 53 42 44 90 data is there. How we can place this data in the memory location? Here they are given. That is, what is that? Assume a hash table of size 15 and hash function is hx x mod 15 x mod perform. Here this is the function x mod 15 performs linear probing with and without replacement for the given set of values. Suppose here these are the data. How we can store this data into the memory locations? For example, this is the hash function x mod 15. X means here this is the key or some record. For example, 0 is there, 15 is there, whatever. For example, I will tell you, suppose here first data 0, where you have to place 0, 0 will place here, 1 1 1, 2 2 second location, 3 3 3 is empty. Here 3 will be empty. For example, we'll show you with a will show with a diagram. Then what are the data? What are the data? 0 1 2 4 72 65 85 87 90 58 52 53 53 42 44 91. These are the data we have to place in this this hash table. This is the hash table we have to place. Here what we'll do first, what is the data? These are the data. First 0 is there, and the function is what? Function is what? hx x mod 15, because since therefore 15 data are there, therefore we are having the function x mod 15. First the data 0 will place 0 location, 1 is there, 1 will place in 1 location, 2 will place into second location, then 4 will place in the fourth location. Next, what is the data? 72 where we can place. For example, 72 15 15 100. Here the remainder is 12. It means that we have to place this in the, what is the data? 72 in the 12th place. Here you see here the 72 data was stored into the 12th place. Therefore, next what is the data? What is 65? 65 means 14 and remainder is 5. Therefore, 65 will place in the location 5. You see here we have stored the 65 the location 5. Then what is the data? 85 85 14 65 15 5 is 75, 10 left with 10. Therefore this remainder here, remainder is 10. 85 divided by 15, 15 5 is 75, remainder is 10. Therefore we'll place in the 85 will place in the 10th location. We'll place in the 10th location. Next what is the data? Next, after 87 is there. 87 15 ಐದಲೇ 75 ಲೆಫ್ಟ್ ವಿತ್ 12 15 5 75 12 means in 12th location we have to store the data. In 12th location we have to store the data, but in 12th location already 72 is placed, because the data at 72 is there prior to 87 here. Therefore what we can do, but the 13th location is free, no data is there in the 13th location. Therefore we'll place the data 87 in the 13th location here. Therefore similarly, before that what we'll do, in every memory location when it is empty we'll put -1, means these are the empty memory locations. These will point to the next memory location. This will point the this will point, suppose same data which will point to same location. At the time using this we'll come to know where we have to store the same data which is having the which will point to the same location. Next we'll see this after 87 what is there, 90. After 87 90 15 4 60 75 16 90 90 means in the sixth location, because 90 the sixth location we have to store the 90. Therefore we have placed in sixth location we have placed the 90, but 90 87 14 sixth location we have to store the 90. Okay. 90 at that time what happens, we'll place this, okay, no problem, we'll place in the 15 90 15 60 15 90. Okay, sixth location will place, okay, first we'll place 90. Next what happens, next 58 15 15 15 15 45 13 is there. In the 13 we have to store 58, but already 13 location 87 is there. Therefore what we have to do, we have to store this into the next location. Next location is free, 58 next location 58 will store 58. Next what happens, now we'll see here 52 52 52 15 52 15 15 3 45 45 7. In seventh location we place 52 in 7 52 place in the seventh location. Next what 53 where will place 53 15 eighth location will place the eighth location will place the 53, like we'll place the data. Next what is the data, 42 next is what 42 15 2 then we'll have 12th location we have to store 52. 12th location 52 we have to store, but already 72 is there. Therefore what we'll do, we'll store into the next location, that is will point to the next location 13, but in the 13 location 87 is there. Therefore what we do, we will mention that we have to store that what is that, how much, which location, 42 12th location, then 87 then this will point to 42, then 87 already data is there. Already data what is, it is in 72 location 42, we want to store in the 12th location, already 72 is there. Therefore, what we'll do, we'll point to 13 location. In 13 location, already 87 is there. Therefore, we'll point to the 6th location. 6th location, where in the 6th location, we are having 90. In 6th location, they have stored the data. 6th location. Okay, I will see this once again. Okay, this is how we can, using this technique, we can store the data in the respective locations. 42, 6 location, 42. Mm. Why we have stored this 6 19 location? Because 90 divided by 15, 90 divided by 15 is how much? 90 divided by 15, 14 4 60 15 7 16 remainder is 0. Therefore, we have to place this 90 in the 0th location. But already 0th location, some data is there, 0 is there. Therefore, here we have to mention which location is free. The third location is free. Therefore, here we'll mention this as we have to store this 90 in third location. Now it is right. 90 third location, and this 90 here no data is there. Sixth location is free. Sixth location is free. Therefore, when we want to store 42 in the 12th location, 42 in 12th location 72 is there. Therefore, what we'll do, we will tell to store in the next location. What is the location? 13. 13 location, in 13 location already 87 is there. Therefore, here we'll mention that go to 6 location. In 6 location, why we'll mention the 6th location means this 6th location is empty, no data is there. I have written 90, but 90 I should not write 90 in the 6th location. Why I have to write 90 in the 6th location? Why? Because here you see this 90 divided by 15, 6th, sorry, here I made a mistake. 6 means 6 is not a location. We have to consider the remainder. 0 location already, data 0 is there. Therefore, which location is free? The third location is free. Therefore, here we have to mention, we have to place this 90 in the third location. Therefore, it will come to third location, and in consecutive the 6th location is free. 6th location is free. Therefore, when we want to store 42 in the 12th location, already 72 is there. It will tell store in the 87, but already it is stored in the 87. In the 30 location 87 is there. At that time, here it will mention the location 6th is free. 6th location is free. Here you have to store 42. Here you have to 6th location we have to store 42, like this. Here we have this 0, here it is pointing to third location, 90 will be in third location. Like this, we can store the data in various memory locations. Like this, we'll store, after this we'll store the 44 in the 9th location because it is free. Then afterwards we'll store what is the data, 91 in the 11th location, 91 in the 11th location. This is how we can store the data using the concept of probing concept of assume hash table size, then performs linear probing with chaining and without replacement. This technique is without replacement. Then this is one more technique is there with replacement. Like so many techniques are you go through this is simple and interesting. Here you don't have programming, only some concepts, tricky concepts, some concepts are there. You go through this, you understand the concepts, it is simple. And you read the book so that few more concepts are there in the fourth module. You go through the book and you will understand the concepts. Okay, the fourth module is over. In next class we'll discuss the concept related to fifth module. Okay.